Hi, this is Yash, and this is Physics 2212 Lab 2, which is revisiting the charge tape experiment from Lab 1. So the overview of this lab, once again, is to understand the interactions between two charged pieces of Scotch tape. In this lab, we will simulate the interactions between the tapes using GlowScript, once again, it's a Python-based software, and computation to determine the charge on each tape necessary to flow above one another. So some key concepts for this lab. We have Newton's second law, which states that the sum of the forces equals mass times acceleration. Coulomb's law, which equals the electric force equals the constant K, Q1, Q2 over the distance squared. We also have the electric field of point charge, which is K, Q over magnitude of R squared times the unit vector of R. And electric field superposition, which essentially states that the sum of the electric field equals the sum of all the electric fields on that charge by other charges. So some assumptions we can make is that we will ignore air resistance for the sake of this experiment. Also, each tape has the same charge, and the charge is evenly distributed across its length. This way, we can separate it in a segment and equate the total charge by summing the charges on the segments, which is the superposition concept. So because this is building upon lab 1, I will review a little about the results of lab 1. So we found the gravitational force by finding the mass times the acceleration, which in this case is gravity. We also found charge Q using Coulomb's law, and then the deficit of electrons by dividing the charge Q over the charge of an electron to find deficit of electrons. We also found the amount of atoms on a piece of tape and the area of the atom to find, like I said, the area of the tape, area of the atom to find the amount of atoms. This way we can find the ratio of electrons to atoms, which we can see here is 1 electron for every 3.6 million atoms. So here's a GlowScript code for lab 1 where we treated the tape as a point charge. And here we got the charge of each tape to float above one another. It's 1.87 times 10 to the negative 9 coulombs. So now I'll go into the lab 2 code and the results. So the GlowScript code for this is obviously way more intricate. We start with the physical constants and then add in the values that I found measuring the tape length with the mass and the distance from each other. Also using the net charge on the tape and wrote code to find the electric field. So here you can see we have the electric force equaling the gravitational force, which is what we want in this experiment. And the result for the force is 1.96 times 10 to the negative 3 newtons. So now for some what if questions. So what if the signs of protons and electrons were switched? What would change about the observations you made with your tapes and other charged objects? Nothing would really change except for the tape would be losing protons instead of electrons. The tapes would still repel each other. The constants remain the same. Now, why are the point charge and line charge computation values different? Because we calculate the line charge value differently. The point charge is just one value, while the charge is the sum of all the integrals along a line of tape. So this is going back to the superposition concept that I talked about earlier. And for our sake, the line charge will be closer to the actual answer just because it's more accurate. Thank you so much.